confusion on what I'm going to ask. I'm going to start today with 8.5, and it looks like, and I'm going to write this down for everybody so you'll know what's going on. Today, we'll probably finish 8.5. Today, we will start and finish 8.5. That means Tuesday, we'll take a look at some graphing of 8.6 and 8.7, okay? Or whatever section that is of sine, cosine, and tangent. And then that means the next Thursday, we will be going over questions, homework questions, and that's the whole class, okay? We might go over homework questions Tuesday also. So that means that either Thursday or the next Tuesday, this is the only time this starts doing this. Y'all are the only class that the TV monitor starts blinking. And eventually it'll cut off. What I'm going to do is I'm going to turn it off. Hold on a second, guys. I'll turn it off and turn it back on. Let's see what it... I don't know what it's doing. But eventually that bottom TV will turn off for some reason. I don't know why it's... And again, I don't know why it's doing it in this class, because I pulled up the PowerPoint in the last class and it wasn't doing that. So if anybody's got any ideas here at the Anderson campus why the TV is doing that, you can let me know and I'll fix it. But it only started just now. And I didn't do anything different. I pulled up PowerPoint in the last and I used this. So I don't know. All right. So it looks like we'll probably maybe test starts maybe Thursday or the next Tuesday. Somebody tell me what the next Tuesday is date-wise. Not next Tuesday, but the next Tuesday.
October
next Tuesday,
2nd.
25th, so this will be the what, the 2nd?
Yeah.
Probably around the 2nd or the 25th. Now, am I talking test and that's it, or that's when it starts? That's when it starts, and I give you 7 days to take the test. Okay? So, the reason I'm telling you this is because I know I've got 9 or 10 up there, 1, 2, 3, 4, 5, 6, 7, that's 15, and then maybe 25 students in here. I got about 4 or 5 that hadn't even started on the homework, okay? So I know that there's some procrastinators out there that's going to wait until the last minute. I'm telling you this right now so you can go ahead and get started and not do it on the 25th or the 2nd when I start the test. Because the way I usually do things is I usually give you 1 more class period to send homework questions after I assign the test. Hypothetically, let's all remember what hypothetically means. What does that mean? Make believe, right? Hypothetically, if I assign the test on the 25th, then I will give you that next Tuesday, which will be the 2nd, that midnight on the 2nd, the homework will stop. That will give you that weekend or whatever, and that Tuesday to send me any homework questions that you haven't sent. You see what I'm saying? I usually give you 1 class period into the test for homework questions. And that's usually for the procrastinators that do their homework at the last minute. Any questions on that? It'll make more sense when I pull up the test and I assign the dates. You'll understand it a little bit more. Okay, now this is the last section before the graphing drills in 8.6 and 8.7. Writing circular functions. Now basically what we are doing is we are writing an angle in terms of S. Okay? Write that down. And that's what that whole paragraph is saying over there. We're writing a angle in terms of S, which means a linear distance along the perimeter of the unit circle. Now that's what we're doing. We are writing an angle. Yeah, just come on in whenever. How was lunch? Was it good? Or did you eat breakfast? You eat pancakes? And...
I don't eat breakfast.
Okay, how was lunch?
I don't eat lunch really.
Well, if you're going to be late for class, you might as well eat. Writing an angle in terms of S, meaning a linear what? Distance. That means an X and a what? An X and a Y. So an X and a Y. And that's what you're going to be doing. You're going to be doing an X and a Y, or you're going to be giving us a distance. The whole point is of the unit circle. Not just any circle, but the unit circle where the radius is equal to what? 1. Is that very important to remember? Yes, because your special angles are not in terms of the angle of 1. Radius of 1. Right, see that? Your special angles, remember you have a 2 and a square root of 3. You know, you have all that. It's different. The radius of 1. Does it matter? No, it doesn't matter as far as the calculations. But you need to make the distinction. We're writing circular angles in terms of S on the unit circle. As far as the calculations are going to be the same. You're going to come out with the same solution whether you use the unit circle or whether you use, the normal special angles. 1/2 and 50/100ths. Is there any difference? No. They're the same mathematically. All right, what does that mean? Well, we'll get to it in just a minute. The radius here is 1. 1, 1, 1, 1. The radius is 1. So that's what we're doing. The main thing you need to remember about circular functions, the number one thing, know where you what? Are. Know where you are. Now, you're going to be given things, and they're going to be asking, blah, blah, blah. First thing you do, okay, where am I on the unit circle? Where am I as far as the angle? That's the first thing you need to do. Because once you do that, you discern whether you have a special angle or you have a raw angle. Special angle or raw angle. Raw angle is like 57 degrees. All right? Versus a special angle, which is 30, 45, or 60. Capiche? So you need to know where you are. Once you know where you are, that's also with the quadrants. Okay, there's going to be quadrant restrictions on these questions. There's going to be, 315 degrees or whatever the case may be. You can't have positive this and positive that in the third quadrant or the fourth quadrant or whatever. So it is quadrant related. So that's the two biggest things that you're going to be doing in 8.5. 8.5 is very similar to previous sections where you're just finding the special angles. It's not that different. In fact, I teach students, do whichever one you feel comfortable with. All right? Write down the circular functions, and they look very, very similar to the previous ones that we've talked about. And remember that when you have a circular function, the cosine is going to be your x. How's that? Because if you want to find, if you drop, and I'm doing this just so you'll see it, if you drop a straight line right there, and if you want to find x, and theta is right here, then what is theta? And you know this is 1. Okay? What do you have? Here's your little man. You have the adjacent and the what?
That's like it put back.
You have the hypotenuse, adjacent hypotenuse.
I said,
Oscar,
wait, tell.
I'm sorry, what?
Sorry, Mr. Hubert.
What's the problem? Somebody got a question?
No question.
Oh, heck no. Nobody's going to ask me anything. Anyway, y'all don't talk to me. I forgot. Y'all don't talk. Y'all were talking to each other. I'm sorry. I just was hoping, you know. Anyway, you got adjacent. Oscar had a what? A hunk. So you've got cosine of theta is equal to a hunk. Now, solve that for x. X is equal to what? Cosine of theta. So your x coordinate will always be the cosine of theta. That's where you get this from right here. That's why it's first. What about the sine? Well, sine is equal to Oscar had. So that's y. So sine of theta is equal to Oscar had multiplied by 1. Sine of theta is equal to. So the circular functions are basically different from your other special angles because the radius is equal to what? 1. And you have to make adjustments, and I'll show you what I'm talking about that. And you'll see that it doesn't really matter whether you use the special angles or whether you use the circular angles. Okay? Capiche? Everybody understand that? Okay. Real simple stuff. This is simple. Not like those freaking questions I never saw the other day. All right. Dang old stop an airplane on a dime in front of the school. All right. Circular functions with a fish eye. I'm sorry, but I've never seen those questions before. Circular function values of real numbers are obtained in the same manner as trigonometric. Okay, that's calculators must be in radian mode. Why don't they just say that? Next thing. All right, let me back up. Well, there we go. Evaluate sine of 3 pi over 2. Well, let me go to the whiteboard. I wish that thing would quit blinking. It's driving me crazy. Giving me a headache. All right, let's go to the whiteboard and let's do 3 pi over 2. And this is why I'm going to show you why it doesn't really make a difference which one you do. So let's go to the handy dandy whiteboard and do 3 pi over 2. Three pi over 2. Well, not many of us think of 3 pi over 2 as an angle. First thing I'm going to do is what? 180 over what? Pi. I'm going to change it to something I know something about. 2 going to 180, 90, right? Yeah. And 3 times 90 is what? 270. 270. So you know that we're talking about the angle of 270 degrees. Okay, let's talk about location. We remember that the coordinate for this guy right here has got to be 0, negative what? 0, negative 1. And we know that the first one is what? The cosine, and the second one is what? Sine. So we know that the cosine of 3 pi over 2 is equal to 0, and the sine of 3 pi over 2 is equal to what? Negative 1. Okay? Now, in a minute, I'm going to show you another angle, and we're going to do it 2 different ways. We're going to do the special angle, and then we're going to do the unit circle. Okay? I think I got it written right here. I think. Yeah. Pi over 6. So let's do pi over 6. Pi over 6. Well, I don't think in terms of pi over 6, so I'm going to change it to 180 over what? 180 over pi, that gives me 30 degrees. So immediately, I do my 30-degree angle, which is what? 1 square root of what? 3 and 2. Now, that's not circular, that's special. So circular would be what? What would this angle be? What would this distance be right here? What would this be? The radius, right? The radius is equal to what? 1. 1 is half of what? 2. So this would be 1, this would be 1/2, and this would be what? Square root of 3 over 2. That's the difference between special angles and the circular angles. Now, let me show you a trick I learned in the war. If I wanted the cosine of that angle, of this angle, and this angle right here, what's the cosine equal to? Oscar had a hunk, so that's square root 3 over 2. Here, square root of 3 over 2 divided by what? 1. What's the answer here? Square root of 3 over 2. What's the answer here? So does it really matter which one you use? No. It doesn't matter which one you use. You can use either one. I don't care. But to me, just me personally, and I'm a layman trigonometry teacher, okay? I'm not, I use things outside in the real world. To me, it's a whole lot easier just to do the special angles and just to know where the special angles are, okay? That's just me. So if you wanted to find the tangent, of course, Oscar had a hunk of apple. You would just take the of in the apple and you put it over itself. And you'd get the same thing. Oscar had, and then, did we do, let's see, Oscar had a hunk, and then you would, the opposite is what? 1, Oscar had 1/2. Well, let's go over here. 1/2 over what? 1/2 over 1 is 1/2. So the sine is equal to 1/2. And the cosine is equal to, so the tangent, Oscar had a hunk of apple, 1 over square root of 3. Tangent equals 1 over square root of 3, which is equal to square root of 3 over square root of 3, which is equal to square root of 3 over 3. Everybody with me? Now do the tangent over here. Oscar had a hunk of 1/2 over square root of 3 over 2, right? 1/2 over square root of 3 over 2, multiplied by the reciprocal, which will be 2 over what? Square root of 3. 2's cancel. You get 1 over the square root of 3, which is multiplied by the square root of 3 over square root of 3, which is equal to square root of 3 over what? It's a miracle. 50/100ths is equal to 1/2. It's what?
It seems kind of redundant.
It is. It's kind of redundant. But if you see the relationship, you won't miss the questions as much. You got to see the relationship. That's what I tell students. See the relationship and you won't miss it as much. Question, gripe, complaint. I went through and I picked out. Now that way you can do the whole unit circle. Now we're just going to pull up the unit circle right quick. And we're going to go from there. And I'm not going to do the whole unit circle. But what I am going to do is go through a couple. All right, there's the unit circle. And all you need to remember, and let's do 60 degrees. All right, which they're not going to give you 60 degrees. They're going to say pi over 3. They're going to say, find the trigonometric functions of pi over 3. And then you're going to say, well, pi over 3 is what? 60 degrees. And then you're going to pull up in your handy-dandy brain, you're going to pull up 60 degrees like that. And then you're going to say, okay, I'm going to find I got to find the x coordinate, that's the cosine. And then I got to find the sine, that's the y. Okay, cosine is equal to, Oscar had a hunk, that'd be 1 over 2. And sine would be, Oscar had would be opposite, square root of 3 over 2. And then I pull up and that's going to be my x, and that's going to be my y. So my x is 1/2, and my y is square root of 3 over 2. And then you say to yourself, well, I better do it by the circular function. The circular function, here's my circular function, there's my 60 degrees. And instead of this being 2, this is going to be 1. And this is going to be square root of 3 over what? 2. And this is going to be what? What's half of? 0.5. This should be 1/2. Okay? And now you do the same thing. Okay, sine, cosine, and sine. Sine, Oscar had a hunk, 1/2 over 1 equals 1/2. That's my x coordinate. Oscar had square root of 3 over 2, right? Oscar, that's the opposite, over 1 is equal to square root of 3 over 2. So there's your x, and there's your y, and you can fill out the whole thing, because if I give you a restriction of between pi and what? Pi over 2 and 2 pi, or pi, sorry, between pi over 2 and pi, that means it's the second quadrant, so you would just flip this 60 degrees like that, and this would be negative 1/2, and this would be square root of 3 over 2, and this would be 1, where this one would turn over and do what? This would be negative 1, square root of 3, and what? 2. So then you would, or you could apply what? All students take what? Calculus, or you could apply that and just use the special angles. So you've got 2 or 3 choices. You can do the special angles and do it that way, or you can do the circular angles, which is the unit circle with a radius of 1, or you could just do the special angles, just use all students take calculus and just apply that. So whichever one you want to do. Question on that? And again, it's not that big of a deal. It's just something that you got to make the relationship with. All right, try 7 pi over 4. Let me get out of this and get to a whiteboard. 7 pi over 4. Well, there it is right there. Leave it there then. 7 pi over 4. What's the first thing you do? Find yourself. 7 pi over 4. 7 pi over 4 times 180 over pi. And 4 will go into 180 how many times? Dang old 45. And 7 times 45. Somebody do 7 times 45 for me.
315.
Okay, so we know it's 315 degrees. So we know it's where? It's your 45-degree angle. 1, 1, be a negative 1, 1, square root of what? 2. And they want to know the cosine. Cosine, Oscar had a hunk, so that's going to be 1 over square root of 2. It's a positive 1 over square root of 2, so that's going to be positive 1 over square root of 2, which is equal to square root of 2 over 2. And then the sine is going to be Oscar had, be negative 1 over square root of 2, which is equal to negative square root of 2 over 2. So there's your cosine and your sine. Of course, you could have done this, the unit circle also, you would have got the same thing. There you go. Now, let's go back and look and see this one. Now, this is excuse me. This is a popular standardized test question. They do the negative angle, which in the real world, that's what you do. You always turn right angles, always. Because everything is based on what? A right angle, everything. So you always turn right angles. You always turn to the right. When you turn a transit or a theodolite, you always turn to the right. But anyway, what angle is this? Well, first of all, let's find out where we are. 5 pi over 3. 5 pi over 3, same as what? 180 over pi. Take out the pi's. 3 will go into 80. 60 times 50 is what? Or 60 times 300 degrees. All right? But it's what? Negative. So that means you're going to start here. There's 270. And 270 plus 30 is what? So if that's 30 degrees right there, then that means we got a what degree angle? A 60 degree angle. And it's in what quadrant? It's in the first quadrant. Now, if you wanted to use the regular, we know it's a 60 degrees, so we know it's 1, square root of 3, 2, or you can use 1/2, square root of 3 over 2, and 1. One is the the special angle, the other is the unit circle. And it says find the tangent. Oscar had a hunk of what? Square root of 3 over 2 over 1/2, or the square root of 3 over what? 1. Which is easier? The square root of 3. So the answer is square root of 3. See? Look at there. It's a miracle. And then we get into this kind of stuff. F of t gives the fraction of the moon's face illuminated by the sun. And then they want you to plug and chug those answers in, which to me, that's calculator work, and you can do that. But look and see what you get. 1 minus cosine 1 minus, where do you have the cosine of theta? Well, that's -1. The cosine of theta, if you look on the unit circle, is -1. All right? So that's where you get -1 from the cosine of theta, 0 degrees. So, and then pi of 2. What is pi over 2? 90 degrees. Well, let's think about it. 90 degrees is right here. And let's think about, if you go up, let's say that's going to be 0 in the x direction and 1. So that means that at 90 degrees, the cosine is what? 0. See what I'm saying? And what else did it ask? Hold on a minute. Okay, what's pi? Pi is 180 degrees. How do you get to pi? Well, let's see. 0 be -1 in the x direction. So the cosine of pi is -1. Everybody see where I'm getting these numbers? Hopefully you see, because I don't know what you see and what you don't, because people won't talk to me. 3 pi over 2 is what? 270 degrees. How do you get 270 degrees? Well, 0 in the x direction, -1 in the y direction, so that would be 0 would be cosine. So 0 would be for 3 pi over 2. And there's cosine of pi. We said the cosine of pi over 2, that's 0. What's 1? Be 1, right?
Right.
Okay. And, pi. Okay, that's pi. I'm sorry. Pi is 180, so that would be -1. And then that last one, 3 pi, is 0 because that's 0 in the x direction. You just got to use the unit circle to navigate it. And you do the relationship between the unit circle and the special angles. Which one ever you want to use, whichever you use is fine. Question on that. You're only talking about maybe 2 or 3 questions on the test coming from this section. All right? Where is most of your questions going to come from? Most of your questions are going to come from anything having to do with the 6 trigonometric functions. All right? I would say probably 4 or 5 questions on your test. Somebody tell me what section is the trigonometric functions introduced, isn't it?
Third.
Which one?
I think it's the third.
No, third.
You said
Third, not the first.
That's the third.
Okay. 8.3. I think 8.3 is where predominantly most of your test is going to come from. Am I going to ask you to find the angle of the fisheye on the moon with the braking of the van? No, I'm not going to ask you any of that stuff. Okay? Now, I might ask you a plug and chug problem, but I won't ask you something that you have no earthly idea of where it's coming from. All right? Don't you think that's fair?
Yes.
Because that question, I don't care. That question did not tell us what C1. Now, the next question did. But it's kind of hard to do questions when they don't tell you what is what. All right, I'm just going to go over one thing right quick for y'all, and that is I want to look at some of the, and this is not going to be difficult, but I want to go over some of the, what is it, 7, what's the next, 8.6, that's it. I want to show you what I expect out of this section. I expect for you to be able, really, is this, no. Is it 8.7 or 8 point, where is the sine functions? I meant the graph. Is it 8 point, somebody look at your outline, please. What's the first 2 sections in Unit 2? 8.6 and 8.7? Or 8.7, 8.8? Which one is it? Everybody should have that outline. Everybody should be turning to that outline. That is the most important handout that I've given y'all, and some people don't even have it.
What was the question again?
Let me see it.
First 2 sections.
No, someone.
8.6 and 8.7. Why does this, it say 8.6 and 8.7? Why doesn't the book say, when I pull up 8.6, it says binomial. Factorials.
That's not our textbook.
Yeah.
That's not your textbook.
Yeah.
No.
Oh, this is 109. I'm sorry. I suck. Let me pull up the actual. Is this? Yeah, there's 111. Okay, this is y'all's book. Sorry. 8.6. There we go. And I'll show you what I expect. And y'all, I couldn't make this very difficult for y'all, but I'm not because I don't see the point. Okay, there. I hit it twice.
There we go.
Yeah, you just got to hit it 2 or 3 times. That's all. Let me go over to slideshow and current and hit and hit and okay. Now what I do want to cover, I want to cover one thing for y'all, and this is kind of a review over something that we did in algebra. Okay, I just want to cover some algebra right quick. Do y'all remember going over this in algebra? Some of you that's had 109 or 110 in the past, and you were given these. F of x is equal to x plus 5 minus 1, and then f of x is equal to 3 times x plus 3 to the second power minus 4, and then f of x is equal to -2 absolute value of x minus 1 plus 7, and then f of x is equal to 4 times x minus 2 to the third power plus 7, and f of x is equal to negative or 3 square root of x plus 2 minus 7, and f of x is equal to 2 times 1 over x plus 3 minus 4, and f of x is equal to 2 times 1 over x squared minus 4 plus 6. Y'all remember seeing those?
Yeah.
And you were told that each one had a horizontal shift, each one had an orientation, compression. Y'all remember that? Pendleton, Oconee, Easley, y'all remember these?
Yes.
Okay, and this one looked like this, regularly, family of graphs, and then this means it's going to be left, 1, 2, 3, and then down 4, and then it's going to be skinny. Why is it going to be skinny? What tells you it's going to be skinny? 3. Okay, all of this, the reason you learned all this in algebra was when you got to the sine and cosine curve. Okay, because all of that plays into this. All right, now if I give you f of x is equal to 2 times the sine of x minus 2 plus 6 or something like that, the 2 is going to make is going to have an orientation and a compression effect. The negative 2 is going to be what? Horizontal shift to the right, and then the vertical is going to be negative. You're not going to have too many verticals on these because the sine and the cosine doesn't shift vertically very much. So unless you have an earthquake. But anyway, I'm just trying to give you some kind of relationship of why you learned all of this, the family of graphs, why you learned all of this in algebra. So whenever you got to trig, you could make the jump from here to here and say, oh yeah, I remember that. That's why. All right, so with that being said, and hopefully you remember that from algebra, we'll go back to our handy-dandy PowerPoint, and that's what we're going to here. All right, and they're saying, remember, the function is equal to blah, 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 and they're talking about the period, and we'll get to that in just a second. And make sure you can graph the sine of x. So make sure everybody in here can take your calculator and make sure you can graph, make sure you can do the window, make sure you can trace, make sure you can do any of all of that on your graphing calculator. I want you to be able to graph the sine, the cosine, and the tangent, and make sure you can apply what happens if I put a 2 in front of the sine. Go ahead and do that. Put a 2 in front of that sine and compare it to the regular. How would you do that? Well, I don't know what y'all know and what you don't know with the calculator, so I'm just going to do a couple of things with you so that way, you know, you'll get a good feel of it. So let's take our handy-dandy calculator and let's pull up the sine. So I'm going to hit y is equal to the sine, and I'm going to make sure, well, I'm going to hit sine first. I can't see the sine. There we go. Close parentheses, and then we'll go down here, and I'm going to make this one darker. Go to the line and hit enter, and make it darker, and then I'm going to hit 2 sine of x. And there's that, and then of course that's the regular. And what happens? The 2 makes it what? It compresses along the what axis? It compresses along the x-axis, and what's it doing along the y-axis? It's stretching. Okay, you got to remember that. All right, because the 2 is going to make it skinnier. All right, what happens if we put the plus 4 on it? All right, let's go back. Y is equal. And let's go down here, and I'm going to do, I don't know what the different, some of y'all have different things. I'm going to make, I want to make it dashed. There we go. The dashed line. We're going to make that. Some of y'all are going, I didn't know my calculator did that. Well, you learned something today. And that's going to be 2 sine of x. And what is, somebody give me a number. Plus 5. So that means a horizontal shot. I can't even talk. X plus 5. A horizontal shot. Is that a Freudian slip? Shot? Horizontal shot? A horizontal shift of 5 to the left. Graph.
Yeah.
And there it is. There's your horizontal shift. And now you can't see it because it's all combobulated. So go back to Y and just take this one out. Clear, delete, clear, and hit graph. All right, there is our 2x function. And then you see the shift. The shift is 2 to the right. Okay? So, or 5 to the right. I can't remember what it was. 5 to the right. And you see the horizontal shift. So I want you to be able to do that. I want you to go through and play with it. I want you to go in and say, okay, y is equal to, what happens if I put a negative in front? And what happens when you do that?
Flips it upside down.
It's going to flip it the opposite direction, yes. So you could do a negative right here. Hit insert, second, insert, and put a negative. And then hit graph. And then there's your regular function. Then it's going to go the opposite direction. Well, you can't see it. Hold on a second. Let me change one thing. Y is equal, change this to x. So, there we go.
Get rid of the plus 5.
Yeah. I'm trying, people. Just hold on. I don't sleep with the calculator in a little bed beside me and sacrifice live animals to it like some of y'all do. But anyway, there we go. Give it a name and all that. And you see from 0, what's it doing? From 0, just look at the origin. What's it doing from the origin to the right compared to the black line? It's flipping it. It's flipping it. And that's what you learned back in algebra. You learned that the negative, and it's amazing to me how many people take college calculus and college physics, and when I ask them, and they're in my Calculus 1 class, and I say, what's happening when you have a negative in front of your sign? And they go, or what does negative tell you in math and science? And they just sit there. Starts with a D. What does it tell you? Magnitude and starts with a D. Direction. Whoever said that. Direction. The only thing positive and negative tell you in science and math tells you direction. Doesn't tell you anything else. And that's so hard for people to understand. That's why you don't have negative distances on highway markers. Because distance is neither positive or what? Negative. That's why you don't have positive and negative highway markers. Okay, I go to Atlanta, it's 200 miles. I come back, it's going to be negative 200 miles. No. Okay, positive and negative tells you nothing but direction. Okay, so A tells you orientation. It also tells you direction. H tells you the horizontal shift. And what does K tell you? Vertical shift. So make sure you take that into account when you do some of these graphs. That's the only thing I'm looking for. I'm looking for you to be able to say, okay, Hubert, that one, that thin line, that's the opposite because it's going in the opposite direction of the regular line. That's what I want you to be able to do because that's all you're going to be asked. So let's look back at the PowerPoint. And they go through and they tell you this stuff. What is, somebody tell me what the range of sine is. Is this the cosine or the sine? This is the cosine. I want to go back to the sine. Did I have the sine up there? Yeah. All right. What is the domain of the sine? All what? All real numbers. What's the range? What is the range doing? Starts with an O. Oscillating. Make sure you know that. That's a test question on any standardized test. What is the range doing with the sine and the cosine? It's oscillating. Does it say that on here? Yeah, there it is. OSC. Make sure you know how to spell it, because I don't. Oscillate. Oscillate means it goes back and forward.
That's it.
They gonna think of a ping pong ball, throwing it in a tube. Ping pong ball does what? Goes back and forth, back and forth, back and forth. It's oscillating. That's the kind of stuff you need to know for the sine and the cosine curve. And the sine, what kind of relationship does the sine and cosine? Another thing, always remember this. What are you actually doing? You're taking the unit circle. Somebody tell me what this relationship is with the unit circle. See how good you remember. Dang old unit circle. We got 0, pi over 2, pi, and then this is 3 pi over 2, and then 2 pi, 3 pi over 2, and 2 pi. All right. What's the relationship between the unit circle and this guy? You're taking a piece out right here. Oh, crap.
Oh no.
Okay, anyway. You're going to take this out, we're going to cut it right here, and you're going to unravel, you're going to roll it out. Okay, think of this as an orange peel, and you're going to cut and you're going to roll that orange peel out, and that's what the result is. So this is, I'm trying to show you. I wish I had a graphic here. Let's say this is that point right there. See that blue dot right there? That blue dot is right here. And the red in another color, let's do a magenta, and you go all the way around the unit circle, and you come back to the magenta dot, and the magenta dot is right there. So what you've done is you've unrolled the unit circle. You've unrolled it. Okay, and it's not a circle anymore. It's a what? It's a wave. Okay, dang old. And the distance between here and here is called the wavelength or period or whatever. You'll get into that, but that's for another time, especially with physics, sound, and light. That's the second physics, I think, or the third. You'll get into plenty of that. I'm trying to remember my physics classes, and that's a long time ago. Question, gripe, complaint, period. There you go, period. Right there, dang old. Period is 2 pi. Question, and this is the kind of stuff I want you to know. Graph y is equal to 2 sine of x, compare it to y, and what will that do? That A will squish it. It'll compress it along the x-axis and stretch it along the y-axis. And that should be second nature to you. Now I'll tell you a little story. We had a teacher here. He just retired, and he was one of those teachers like Dr. Harden. Dr. Harden, if you go to Clemson and go down to the bottom of Martin Hall, go to 101. There's an office. It's got a little plaque. Dr. Harden. He stayed in that office. The office was about as big as a bathroom, little bathroom. And he was the department head there for about 125 years. And he was a little man about this tall, and he wore polyester brown pants, and a light brown shirt every day. That's what he wore every day. And he didn't talk. He grunted. And do you know what that meant? That meant, you know how to do this. And we didn't have graphing calculators back then, okay? And he commenced to doing this, okay? And I'm going to tell you something. You're talking about somebody confused? This right here can confuse you. And then before Clemson, I had a teacher here, and some of you may have heard of him, Joe Stearns. He was a very good teacher, but he would confuse the heck out of me when he did that chart. And then he would do a minus. He would do a minus sign F minus 2 like that. And then he would just blow the class away with the horizontal shift. So be very thankful that you have what? The graphic calculator, so you can actually see the vertical and horizontal shifts, or you can see the compression and the stretching, or the compression and the stretching on your calculator versus what? This, because this right here would lobotomize you. It will after you look at it enough. So be very thankful. And then I had another teacher, Dr. Ruppel. He would just go up. He would come to class and say, "All right, your midterm is on this day. Make sure you show up, and your final is on this day." And then he would go up into his office at the 3rd floor of Martin Hall, and he would play Tetris all day. And he was there for about 126 years. So hopefully things have changed at Clemson in the last few years. And look at what they're going over. They're going over the same thing that I just went over with and I can't believe they used exactly the same numbers because I didn't look at this before class. Anyway, and make sure you know what the amplitude is. Amplitude is the same thing, it's the same shape, but it's either going to be stretched or it's going to be the maximum values, period. There you go, cosine of 2/3 x over 1 period. Graph that, compare it to what? What am I going to compare the cosine of 2/3 x to? Cosine of x. I want you to compare everything to the basic model, just like the parent graphs. So if you really want to put it in perspective, some of you, if you had a teacher worth anything, meaning me, no, I'm just kidding. If you had a teacher, they probably told you to take your piece of paper and draw 8 to 10 sections like that. I don't know if they told you this or not. And they told you to do f of x is equal to x, and then they said that's a what? That's a linear. And then f of x is equal to x squared, that's a what? That's a parabola. Y'all remember doing this? And then f of x is equal to x to the odd power, and that's going to look like what? It's going to look like a cube or a fifth, the ending behavior being opposite directions. And a quartic, meaning f of x is equal to x to the even function, it'll look like a parabola, only the higher the function, the more squared out the what? The u is going to be. F of x is equal to the square root of x. Looks like that. F of x is equal to absolute value of x. Absolute value, absolute vodka. Vodka and value starts with a V for all you alcoholics. Okay? F of x is equal to 1 over x. That's half of a volcano. If that's half of a volcano, then what's 1 over x squared? F of x is equal to 1 over x squared would be the whole volcano. Okay? And then now you can add one more. F of x is equal to the sine of x. Sine, what did it look like? Started at 0 and what? There you go. Now everything now that you see with sine of x is going to be compared to your parent graph, which is the basic model. And then this cosine, f of x is equal to cosine of x, is going to be what? It don't start here, it starts where? It starts like 1 over, I can't remember. I think it starts at 1 and goes like this.
Yeah.
Okay, well, you draw it 3 times and it shows up finally after the 3rd time. So, and just add one more, and that's the what? The tangent. And now you're going to compare everything that you do in 8.6 and 8.7 is going to be compared to those 3. Add the tangent, and that's going to be compared to those 3. I will only test you pretty much on sine and cosine.
Sweet.
Okay? Because that's pretty much what you use in Calc 1 and Calc 2. All right? Be aware of tangent. Be aware of it like you you're aware of, other things in math, but you never use, be aware of it and make sure you know how to compare it to the parent graph, and you'll be good to go. All right, so what I want you to do over the weekend is I want you to work on all the homework. Don't work on 8.5 and 8 points. Don't work on sine and cosine yet. I'm gonna fix that this weekend, and I'll put revised on it so you'll know that I've changed it. It'll say 8.5 homework revised, or what is it? 8.6, 8.7, 8.6 revised. When you see the word revised, that means you can do it. Okay? Because I don't want you doing a lot of it because it's unnecessary. I want you to work on 8.1 through 8.5 over the weekend, and over the weekend you'll see the 8.6 and 8.7 change to revised, and then you can work on it. I want to see questions come in Tuesday, and then we'll go from there. Okay, y'all have a good day.
Hey, I have a
Any
question.
questions? Stay after class. Be glad to answer them.